So in this lesson, we're going to talk about rate of change, or what is known as slope, also known as, sometimes in math, we depict it with little m. That's the symbol we use for slope. Okay. So example 1. The graph shows how the distance changes over time during a trip. So if you look at the graph, here's time, so that's our independent variable. Distance is our dependent variable. So as time goes by, we're traveling at a certain speed. Speed comes from distance. So in 1 hour, we travel 75 kilometers. 2 hours, we travel 150 kilometers. 3 hours, we travel 225 kilometers, and so on. So what do we notice about the relationships of this graph? For one thing, as time increases, the distance increases. You can also notice that it's linear, which means that it's a steady speed throughout the whole time the car is traveling. So average speed is defined as distance traveled divided by time taken. So speed again is just basically change in distance over change in time. So we're going to calculate the average speed for the distance traveled by the car shown in the graph. So if we look at this graph, we need to look at the change in the distance. So here it's going from 0 to 75 in 1 hour. So this 75 is the distance and the time is 1. You can pick any 2 points on the graph to get the same thing. So our average speed is equal to the change in the distance over change in time. So we got 75 kilometers divided by 1 hour. So we get 75 kilometers per hour. As I said earlier, average speed is also known as rate of change or slope. It measures the steepness of a line. So we talked about steepness in previous lessons. We know the more steep a line is, the faster it's going, and the less steep, the slower. Rate of change, also known as slope. Sometimes we use little m for slope. Again, it's just the change in the dependent variable. So this triangle represents change. In math, it's a symbol used for change in the dependent variable, sometimes known as our y variable, over the change in the independent variable. Example 2. On the day that Brian walks to school from home, it takes him 5 minutes to walk 1 kilometer. Assume Brian keeps walking at this rate. Make a table to show his distance from home. It takes Brian 20 minutes to get to school. So at 0 minutes, he's going to be 0 kilometers. He hasn't walked. In 5 minutes, we are told that he walks 1 kilometer. If he keeps going at this rate every 5 minutes, so this is going up by 5s, he's going to go 1 kilometer. So for 1, it's going to be 2. Another 5 minutes pass, he's going to go another kilometer. Another 5 minutes pass, he's going to go another kilometer. Let's graph this. This is time. That's our independent. And this is distance in kilometers. Let's go create a scale. So I'm going to just go by 5s. And simple, just go up by 1s. So 0 kilometers is at 0 minutes. 5 minutes, he went 1. 10 minutes, 2. 50 minutes, he was 3. 20 minutes is 4. So I'm going to draw a line. It's a linear relationship because it's steady. It's the same rate that he's traveling. Determine the rate of change slope in the graph. What does the rate of change represent? So let's pick 2 different points this time. I'm going to go from 10 to 20. So I'm going to look at the change in the independent and dependent. So this is time. So from here to here is 10 minutes. It's from 10 to 20. And from here to here, I'm going from 2 to 4. That's 2 kilometers. So remember, our slope or our rate of change is equal to the change in the dependent over the change in the independent. So we got 2 kilometers. That's our dependent. It's our y variable. It's the one that goes up and down. And our independent is 10 minutes. So we have 1 kilometer and 5 minutes. So I just reduced it. And to get an actual speed, you can just divide it out to say it's 0.20 kilometers per minute. This slope represents our speed. This slope represents that Brian is walking 0.20 kilometers per minute. How far is Brian's school from home? Well, we look at it. It takes him 20 minutes to get to school. So if we go to 20 minutes, his school is 4 kilometers away. So you can see that here. And his average speed per hour. So we found out per minute. We want to find out per hour. So I'm going to write it out like this. We know there's 60 minutes in 1 hour. I like to write it out like this because if I see the minutes over minutes, I know that that's going to disappear. Divides out, and I'm left with 0.2 kilometers. Oops. 0.2 times 60 kilometers over hours. So again, this will cross that out. That's how I know that's the right way to multiply. And I'm left with 12 kilometers per hour. Calculate the average speed, also known as rate of change for each section. So if I look from A to B, the average speed, so I'm going to find the change in the distance. So from here to here. So we're going from 0 to 4. Over the change in the time. Excuse me. So it's 4 divided by 2, which is 2. We'd like to write the units, so that's 4 meters, 2 seconds, so it's 4 meters in 2 seconds, so that leaves us 2 meters per second. From B to C, we're not traveling anywhere. 0 meters in 3 seconds. That's really 0 meters per second. There's no change in the distance, so that's when you know the speed is 0. C to D. Let's see. Nice to draw triangles. That's how you get your rate of change. So from 5 to 10, that's 5 seconds. And from 4 to 8, that's 4 meters. So we're talking about 4 meters in 6 seconds. So it's 0.8 meters per second. And lastly, from D to E, you have 8 meters in 2 seconds. So 8 meters, 2 seconds. That's 4 meters per second. So you can see, the idea is you're finding the change of the dependent and you're dividing by the change of the independent. Independent's always horizontal, dependent's always vertical. So in each one, you're looking for change in the dependent and dividing by the change in the independent. Okay, the last example I'm going to do is for a science experiment. Mary puts a glass of water in the freezer to find out how quickly it freezes. She measures the temperature of water every 2 minutes until it freezes. She created a table of values for her data. So here you have your time and here you have your temperature. So when the time is 0, temperature was 20 degrees Celsius for this glass of water. In 2 minutes, it became 19, so it's getting colder, it's going down. So Mary needs to write a lab report to determine the rate of change of the temperature. We're going to graph the data, and we're going to use any 2 points to find the rate of change. So let's graph it. 0, 0. Whoops. 0, 20, not 0, 0. Starts off at 20. And as time goes by, it gets colder. So every 2 minutes, it goes down 1 degree. Okay, so now we're going to find the rate of change. Again, now it's downwards because it's getting colder, so the temperature is actually decreasing. So I'm going to pick any 2 points. I can go from the start to the finish. So I'm going to go from one big triangle. So from 10 to 20, that's 10 degrees. And from 0 to 20, that's 20 minutes. So the rate of change, also known as slope, is going to be the change in the dependent, so the one that goes up and down. So it's 10 degrees Celsius and over 20 minutes. Now there's something I gotta be careful. So it's decreasing 10 degrees. So I'm gonna write minus 10 degrees. Very important. With my highlighter. Highlight that. So it's going down. That's why it's negative 10 degrees, which means my degrees Celsius is going to be minus 0.5 degrees Celsius per minute. So this rate of change, it represents that the temperature is decreasing by 0.5 degrees Celsius each time. And there you have an introduction to average speed in relation to slope and rate of change.